Hello everyone, I am Daniel Esteban Briceño Porras, and today we're diving into a fascinating topic from the world of exercise psychology. How does the human body produce energy, use it during exercise, and how do we measure it? Based on research and case reference like Wilmore and Costil and McCardle, we'll break this topic down so it's easy to understand and apply. Whether you're an athlete, an student, or just curious about how your body works. Come on with me to the section 1 energy for a cellular activity. Every moment we make, blinking, walking, or sprinting requires energy. This energy can exist in various forms chemical, thermal, mechanical, or electrical. But for our cells, especially during exercise, the key from is chemical energy stored is in ATP, adenosine triphosphate. Our body produces ATP by breaking down nutrients from food, mainly carbohydrates, fats, and proteins. Each plays a different role in how energy is delivered. Energy of nutrients, bueno, principal carbohydrates. Thin carbs as your body high octane food, especially for intense works. They are broken down into glucose, which is stored as glycogen in muscles and the liver. During high intensity efforts, the body rapidly converts glycogen into energy even without oxygen, perfect for sprints or quick bursts. Second, the fats. Fats are like your long distance energy tanks. They provide more than double the energy per gram compared to carbs, but they did need oxygen to be used efficiently. That's why they are used during low to moderate intensity, long duration activities like jogging or cycling. And the last ones, the proteins. Proteins are the builders. They repair muscles for enzymes and supports hormones. While not a primary energy source in prolonged or intense exercise, especially with long glycogen proteins can be broken down to super energy production. Before continue, I will go to expose the terminology. Bueno, total daily energy expenditure or TDEE that has three main components: basal metabolic rate (BMR), energy your body needs at rest just to stay alive. Second, thermic effect of food or TEF, energy used to digest and process food. And the last one, physical activity energy, PAE. All energy used in movement, and it's the most variable. For sedentary people, the BMR can account for 60 or 75% of total energy use, while physical activity might rise to 30% or more in active individuals. Continue to the section 4, the ATP production systems. The body produces ATP through three energy systems, each oriented to different intensities and durations. The first system, ATP PCR system. This is the fastest anaerobic system. It uses stored to phosphocreatine to quickly regenerate ATP in the first 5 to 10 seconds of intensive activity like sprinting or lifting. But it's short life. When PCR runs out, the body shifts to the next systems. The next systems is glycolytic system, anaerobic. This system breaks down glucose with oxygen, producing ATP and lactic acid. It powers activity lasting from 30 seconds to 2 or 3 minutes, like 400 meters runs or HETT. The third system is an oxidative system, is aerobic. The most efficient and sustainable, it uses oxygen to break down carbs, fats, and proteins to generate large amounts of ATP, ideal for long duration, steady state activities like distance running or cycling. How measuring energy use? So how do we measure how much energy we're using? Um, we have four methods. The first one, direct calorimetry. Measure heat production in a special chamber, very accurate but expensive and impractical outside the labs. The second, indirect calorimetric, more common, measures oxygen consumed and CO2 produced to estimate energy use. It's portable, practical, and widely used in sports science. The third, isotope methods. Uses labeled water isotopes to track energy over days in real life conditions. Very accurate but expensive and used mostly in research. And the last ones, aerobic estimated. Because anaerobic energy doesn't use oxygen, we rely on lactate measurements, oxygen deficit, and post-exercise oxygen consumption, or EPOC, to estimate it indirectly. For the conclusion, understanding how the body produces and uses energy helps to use optimize training, nutrition, and recovery. Whether you're training for performance, working in health science, or simply interested in human psychology, these concepts are the foundation for smart, effective physical activity. If you, thanks to all for paying attention, and I hope to see you in a next video. Bye bye.